Hello, in this statistics tutorial we're going to talk about computing planned contrast or custom hypothesis tests in R. Now, this video is not going to be about the theory of planned comparisons, why they'd be used, when they'd be used, or indeed the logic of choosing a planned comparison. I've got another video on that. In this video we're just going to focus solely on how to do it in R, because I think that needs a video in and of itself because it's quite complicated. So this is one way ANOVA planned contrast. Let's dive into our example. So I've got an R data frame open here, and you can see we've got, in this example, we've got three groups that are all measured on one independent variable, and the dependent variable. And the idea of this fictitious study is that we give people a mood induction message to collect for some bias in mood judgment, and they were either given a control condition, so we should expect nothing should happen to them, a neglect correction condition, which was supposed to make them more happy, an impact bias correction condition, which we would expect to make them less happy, and we saw in the one-way ANOVA video that there is a difference between these groups, but we can either follow that difference with post hoc tests or planned comparisons. Now, we saw in the planned comparisons theory video that while post hoc tests just compare each group to every other group and don't really tell us any more than our original ANOVA, we can using planned comparisons we can do different comparisons. So in this example, we're going to compare the control group to to all the other groups in the first comparison, and then in the second comparison, if the first one's significant, we're gonna forget about the control group and then see separately if there's a difference between both experimental groups. So how do we actually do that? Well, first thing we need to do is actually define our contrasts. So I'm going to say we're just going to do this as vectors, standard rows of numbers in R. So I'm going to say C1 equals C, and we saw in the previous video that we need to give each group coefficients, and the coefficients are assigned according to what the order of the group. So the first number that we define will always apply to the control group, the second number we define will apply to the neglect correction group, and the third number we define will apply to the impact bias correction group, or however many groups you've got. We saw in the previous video as well that anything that isn't in the particular contrast should be given a coefficient of 0, and any two things that are being compared should be given equal but opposite signs. So let's see how to do that. Given that in contrast, when we want to compare the control group to the neglect correction group and the impact bias correction group, I want to give the first group coefficient of 2 because it's being compared against two things, and the second coefficient of -1, so that the two group coefficients of -1, so that the total sums to 0. Second comparison, we're going to want, we've already looked at what we wanted to look at with the control group, so we don't need to look at that again, so we can give that a coefficient of 0, and the first group a negative coefficient of -1, and the second group a coefficient of 1. Now we get into the R stuff, and what R actually needs to compute these comparisons. Well, first thing we need to do is put the total comparisons into an object in themselves. So to do that, we're going to use the cbind function, and we're going to say comps, standing for comparisons, equals the cbind function and it equals, we want to bind together both our comparisons, so C1 and C2. We're then going to say that what variable these contrasts apply to. Well, we've only got one grouping variable here, so they are relevant to they are associated with groups in the group variable. So to do that, I'm just going to say contrasts for the data object and the group variable are equal to what we just created in the comps object. The next thing is to run our ANOVA as normal, so we're going to say model equals ANOVA and in this case happiness is being predicted by group, and we want to give the data that we want that to apply to is the data object. So when we do the analysis, because we've already run that contrast function, we don't need to tell R anything special. We just give it our variables. So if we run that, it computes our ANOVA. Now the way the special thing we need to do is make sure it's split at when we output it. So to do that, we're just going to say give us a summary of our model object, but instead of just running it as usual, we want you to split it a bit because there's two contrasts there. So we want to say split and set that equal to, we want to make a list and the list is going to be made according to group, because that's what that's the variable that the contrasts are defined for, and the different parts, the different elements of that group variable are themselves going to be split according to a list. We can now name both our comparisons, so I'm going to say the first one is control versus experimental. That's the name for the first contrast we set, because it compares the control group to all experimental groups overall, and say that equals 1 because it equals the first set of coefficients we set, and then for our next one we want to say neglect correction versus impact bias, because this is only comparing both for experimental this is comparing our experimental groups. So say neglect correction versus impact bias equals 2. If we run that, you can see we get both our comparisons. So the first one testing whether the mean for the control group differed against the mean for all our experimental groups is significant, and there's the details you need to report it. F statistic, degrees of freedom, and the second comparison, our impact bias versus neglect correction group, was also significant. So nothing to do with the control group, just comparing neglect correction to impact bias was also significant. So that was a quick demonstration of how to do planned contrast in R. Like I say, if you've not seen the theory video, that probably didn't make much sense, but I hope if you have, you now understand planned contrast and that was useful. Thank you very much for watching. Bye bye.